Now I would like to share with you the second property, that is the shifting property. The Laplace transform of the exponent AT/ft, if the shifting property, you will get the Laplace transform of s minus a. Now let's look at the example. Example 4.5, by applying the first shift theorem, evaluate the Laplace transform of t squared exponent 2t. So if you look at here, the question is t squared exponent 2t. So bear in mind that from the Laplace transform table, you have t power of n equal to n factorial divided by Sn plus 1. So this is the Laplace transform of Tn, you will get this one. And whereas Laplace transform of exponent At, you will get 1 over s minus a. Okay, 1 over s minus a. So from the question, you have the Laplace transform of the t squared. Okay, Laplace transform of the t squared, you get 2 factorial divided by s power of 3. So what about the second one? What about this exponent 2t? Okay, this exponent 2t equal to 1 over, for the exponent at, you get 1 over s minus a. So you need to combine the Laplace transform of these two. So means that you combine these two. So what you need to do is for the t power of 2, you obtain this one. And then for the exponent, you obtain this one. So for the combination of 2, you combine this and this by substituting the s into s minus a. Okay, this means that Laplace transform of t squared exponent 2t will equivalent to 2 factorial. Okay, the s power of 3 here, the s I substitute with s minus 2, in which the exponent at is equal to 1 over a. So if I have exponent 2t, this means I have 1 over s minus 2. Okay, so I substitute this, substitute the s with the s minus 2. Okay. And second question is Laplace transform of 4 exponent negative 3t sine 5t. Question B is the Laplace transform of 4 exponent negative 3t sine 5t. So from the table of Laplace transform, you obtain the sine at equivalent to a over s squared plus a squared. So this means that Laplace transform of the sine 5t, you will get 5 over s squared plus 5 squared. And we still left the exponent negative 3t. Okay, this is the first property, that is the a is equal to negative 3. That is, we refer to the shifting property here, exponent at, ft is referred to the fs minus a. Okay, so the case now is negative 3t. So this means that the a is negative 3. So a is equal to negative 3. So we replace the symbol s, okay, by replace the symbol s by s plus 3. So now you will get like this, okay. Four is a constant, we'll take it out, and the Laplace transform of the exponent negative 3t sine 5t. Okay, so for the sine 5t, you have the 5, okay, divide by s squared plus 5 squared. Okay, s squared plus 5 squared. But you don't forget the exponent negative 3t, you have the shifting, so it's a s plus 3. So you replace the s here with s plus 3. So s plus 3 squared plus 5 squared. So now, after I multiply in, I get s squared plus 6x plus 9 plus 25. So this will equivalent to 20 divided by s squared plus 6s plus 34. Okay? Do you understand? And then next we move to another equation, Laplace transform of t plus t squared plus t over 3, t power of 3 divided by 6, and then exponent t. So we can separate it into Laplace transform of t exponent t, and then Laplace transform of t squared exponent t plus 1 over 6 Laplace transform of t power 3 exponent t. Okay, so also we can get from the Laplace transform table in which the t power of n is equal to n factorial divided by s m plus 1. Okay. So again, t we can get is a 1 factorial divided by s power of 2. And then we have the exponent t. So based on the first shift theorems, we can get the s minus 1. Okay, because it's 1t, so s minus 1. So therefore, we can get it here like 1 over, okay, for the n factorial, right, 1 over s, and then the s you change to s minus 1. For the second one, okay, t power of 2, so we have 2 factorial divided by s plus s power of 3, and then this is exponent t square. Okay, t square exponent t. So this is also again is a s minus 1 power of 3. And then plus with 1 over 6. For t power of 3, you have 3 factorial divided by s power of 4. And then for the shifting, we change the s to s minus 1. And now we simplify. This one is 3 times 2 times 1. We can get 6 and we cancel out this one. Okay. So maximum is s power of 4. S minus 1 power of 4. So we can get, now the first one is s minus 1 square. We still not enough. So we need to multiply s minus 1 power of 2. We need to multiply these two so that it is the same as s minus 1 power of 4. And then plus with 2 factorial s minus 1 because we're not enough. Here we only have power 3. We need one more for s power 4. And then plus with 1. Okay. And now we can simplify. Okay. We expand this one and multiply in this one. So we get s squared minus 2s plus 1. Then plus 2s minus 2 plus 1 divided by s minus 1 power of 4. So this one cancel out. This one and this one also cancel out. I left s squared divided by s minus 1 power of 4. Okay, so that's it for the shifting property. Next property is the derivative of transform property. So this is the property for the derivative. If the Laplace transform of the ft is fs, for n is 1, 2, 3, and then Laplace transform of the t power of n ft is equal to negative 1 power of n, the dn over ds power of n fs. So this is the derivative properties. Now let's look at the example 4.6. Evaluate the Laplace transform of the t e to t. If you look at here, this is the Laplace transform of the t exponent to t. So this is the t exponent to t. And from the derivative of transform property, you have t power of n ft. Okay, you are equal to this one. So what does it mean? This means that t power of n multiplied with the ft. So this ft is what? This ft is this one. Okay, it's referred to this one. So therefore, with a Laplace transform of the exponent to t, you will get 1 over s minus 2. This is the shifting properties. So you will have the 1 over s minus 2. Okay, s minus 2. So therefore, Laplace transform of the t e to t, I will write it in 1 over, okay, negative 1 power of 1. So you have negative 1 d over ds, Laplace transform of the exponent to t. So just now we already find Laplace transform of the exponent to t. You get 1 over s minus 2. So you write down or you substitute. Okay, so we need to differentiate with respect to s. So this one I rewrite it. So I will get s minus 2 minus 1. Okay, this is easy for the derivative. So I differentiate this one. So I get negative 1, s minus 2, negative 2. Okay, I differentiate this part. So I get 1 over s minus 2 square. So this is the answer. Or I can use, okay, this is using the derivative of transform properties. Otherwise, I can use the other method, that is using table of Laplace transform, in which the Laplace transform of t equal to 1 over s square, where s, so Laplace transform of t exponent to t, so means that I substitute the s with s minus 2. So therefore, I get 1 over s minus 2 square. Because the t, you will get 1 over 1 factorial over s, okay, 1 factorial over s square. For this one, it's a shifting. So this shifting, I will get s minus 2. So I substitute the s with s minus 2. Okay, or you can use the tabular method. The tabular method is the formula method. Okay, or I write it here, okay, using a tabular method. Laplace transform of the t e to t equal to integration from 0 to infinity, exponent negative st, exponent to t dt. So this is the formula, okay, for the exponent, for the Laplace transform. So now I combine the both, okay, limit from t goes to infinity, 0 to t, exponent, I combine these two, so I can get exponent negative s minus 2 t dt. Okay, for the tabular method, so this part I can do for the tabular method. Okay, so left hand side is the differentiation and the right hand side is integration. T and exponent negative s minus 2t, this one. T is the differentiation, exponent negative s minus 2t is the integration. So I differentiate t, I get 1, and differentiate 1, I get 0, and integrate exponent negative s minus 2t, I get exponent minus s minus 2t divided by negative s minus 2. And I integrate again, I will get exponent negative s minus 2t divided by s minus 2 square. Okay, so for tabular method, so this is the method, the procedure. So this is the plus, this is the minus. So I will take this value into, substitute into this equation. Okay, I bring down. So I will have integration of this part. I will have the t exponent negative s minus 2t divided by negative s minus 2. This means that this one will multiply with this one, minus with this one, multiply with this one. So minus exponent minus s minus 2t s minus 2 square. The limit is from 0 to infinity. So when I substitute the t with infinity, so I will have the exponent negative infinity, I will get 0. And same to here, exponent negative infinity, I also get 0. Okay, then minus with, when the t is substituted with 0, I still get a 0. And then for this one, also same. When I substitute t with 0, I get 1. Over s minus 2 square. So this will equivalent to 1 over s minus 2 square. Right? Second question is the Laplace transform of t square sinh 4t. So as you know, Laplace transform of the sinh 4t, from the table of Laplace transform, you get 4 over s squared minus 4 squared. So for this question, I use the derivative of transform. I get, okay, d squared over ds squared. So for the front part is negative 1 power of 2, okay, because t power of 2, so is positive 1, and derivative of Laplace transform of ft. So I get d over ds squared. For Laplace transform of the ft, I get 4 over s squared minus 4 squared. So this is the second order. This means that I need to differentiate for 2 times. Then 4 s squared minus 16 minus 1. Okay, and then next, first derivative, so I get negative d over ds. I differentiate for the inner part first. So I have differentiate is the minus 1, and then 4 s squared minus 16, then negative 2. Then you multiply with 2s. That 2s is from here. Okay. So now I have d over ds and get negative at s over s squared minus 16 square. Or I can rewrite it. Or I can write it right. Okay, I'll put at the here, under here, d over ds, negative at s, and multiply with s squared minus 16 power of negative 2. It is the same. So now we have we need to differentiate one more time again. So I write in this way. I assume this one is u. I assume this one is v. So u is equal to negative 8s, and u prime equal to negative 8, and v equal to s squared minus 16 power of negative 2, and then v prime is negative 2, s squared minus 16, negative 3. Okay, and I differentiate 2s squared, I get 2s. So product rule u v prime plus vu prime, I get negative 8s multiply with 4, negative 4s s squared minus 16 power of negative 3 plus with v is s squared minus 16 power of negative 2, and then u prime is negative 8. So when I simplify, I can get 32 s squared divided by s squared minus 16 power of 3 minus 8 divided by s squared minus 16 power of 2. So I can simplify this one. I put the denominator equal to s squared minus 16 power of 3. So this one I copy down, equal to 32 s squared minus, and for this side I multiply with s squared minus 16. So you have 8s squared plus 12s, 1 to 8. Okay, that is the 8 times 16, you get 1 to 8. So when I simplify, I can get 24s squared, okay, plus with 1 to 8 divided by s squared minus 16 power of 3. Or I can write down as, okay, factorize it, 3s squared plus 16 divided by s squared minus 16 power of 3. Okay, so this is about the derivative of transform property. Hope you can understand and enjoy watching. Thank you.